Welcome. I'm so excited to have you here again. Let's take a look at question 3 of the JAMB Physics 2020. It's going to be really engaging and exciting. The question goes thus: which of the following is a neutral equilibrium? We're given 4 options, so I would want to quickly represent each of the options. By that I mean I'll have to draw it. Let me pause the video to do that. All right, so we're back. So you can see I have some drawings. So for this is for option A, which says a heavy weight suspended on a string. Okay, this is the heavy weight that is suspended on this string. Okay, then for the option B, which says a cone resting on its slight edge. That is, for this one, C is the heavy base table lamp. This is the lamp, and D is the beam of a balance in use. All right, so the concept that we need to look at is we are told that one of these options is a neutral equilibrium, and neutral equilibrium is just one out of the 3 states of equilibrium, and we are going to first of all take a look at the 3 states. Then we can identify which of the options, which of the states that whatever states that each of the options belong to. And it is quite easy to say, of course, there are 3 states. Let me just quickly write that here. We have the stable, unstable, and the one given in the question, the neutral. Okay, so these are the 3 states of equilibrium. For the stable state equilibrium, you could say that when the object is slightly displaced and it returns back to its original equilibrium position, it is stable. And when it is slightly displaced and it doesn't return to its original equilibrium position, it is unstable. Then when it is slightly displaced and it changes the position of the original equilibrium, it is neutral. But that sounds too simplistic, so we want to really go in depth to understand stability relationship with center of gravity, because that really are going to tell us more details how to get the answer. But basically, let us start. Stable equilibrium. A body is said to be in a stable equilibrium if it comes back to its original position. I just said that when it is slightly displaced. For example, a cone. That's why I drew these cones here beneath here. A cone, okay, standing on its base. This one here, the center of gravity of the cone is nearer the base. This is the center of gravity here, is nearer to the base of the cone. Okay, so when this cone is displaced, its center of gravity is raised. Take for instance, if it displayed in to the right here, the center of gravity is raised. That is what it's trying to say. So a cone in stable equilibrium should have a center of gravity as low as possible. The center of gravity here is low as possible, so the vertical line through its center of gravity should be within its base. Okay, what that is saying is the moment this vertical line is crossing being more than this baseline, let's say it crosses up to this point, it will topple off, and that is what happens to this second state. And this second state is the unstable equilibrium state. All right, so once you slightly displace this, the center of gravity will be lowered. Okay, that is, if you displace it now, the center of gravity will come down. Okay, it will be lowered, and it will return back to its original equilibrium. Okay, so that's what makes it unstable. The first one is the stable equilibrium. So you see that the center of gravity has a relationship to do with the stability. Okay, so then for the neutral equilibrium, a body is said to be in equilibrium if, on being slightly displaced, it does not come back to its original position. Of course, the unstable equilibrium too won't come back to its original position, but get it right now, but occupies a new position similar to its original position, that is the neutral. It will occupy another new position that is similar to the original, okay, equilibrium. So that is what makes it the neutral equilibrium. So a cone resting on its side is in neutral equilibrium. If the cone is pushed slightly, its center of gravity is neither raised nor lowered, but it remains at the same height. So anytime you slightly push this, it will remain as it is. For option A, if you slightly displace this heavy weight, it will definitely come back to this position. Let's say you pull it down, it will definitely come back to its position. So this is an example of a stable equilibrium. B is an example of a neutral equilibrium, because it is once you slightly displace it, it's just going to change the position, which is similar to the original equilibrium position. Okay, then for C, if you slightly displace it, depending on how this is placed anyway, if it is well balanced, it's going to come back to its original position. So this one could also be taken as an example of a stable equilibrium. Then for D, obviously, if this is also slightly displaced, it will come back to its original position. Either on both sides, it will come back to its original position. So the other three options are example of stable equilibrium, while option B is the only option that is an example of a neutral equilibrium. I hope you're sharing this video. Share this video, like this video, and make sure you give this video a thumbs up and leave a comment in the comments section. Thank you for watching. See you in the next video. Bye for now.